And welcome students to our next lesson on references and class parameters. We're going to today discuss one of our last theoretical lessons, which is that of class parameters. So getting started. Strictly speaking, all parameters in Java are what are known as call by value parameters. This means that when an argument is plugged in for a parameter of any type, the argument is evaluated and the values obtained is used to initialize the value of a parameter. And recall that for all intents and purposes, a parameter is really kind of like a local variable. It only belongs to that method. However, in the case of a parameter of a class type, the values plugged in is a reference or memory address, which makes the class parameters behave quite differently from parameters belonging to a primitive type. So with class parameters, let's look at this one. So recall the following makes variable 1, variable 2 named to the same object. So toy class variable 1 equals new toy class, Joe 42, toy class variable 2, variable 2 equals variable 1. So any change made to variable 2 is in fact made to variable 1. Same thing happens with parameters of a class type. The parameter is a local variable that is set to equal the value of its argument. But if its argument is a variable of a class type, this copies a reference into the parameter. So the parameter becomes another name for the argument, and any change made to the object named by the parameter is made to the object named by the argument because they're the same object. And so largely it's a lot of kind of what we just talked about with our previous lesson with the references, except now we're just applying the same kind of idea, not just to variables but all or class objects, but to the parameters that they can have. Thus, a method can change the instance variable and objects given as argument. Some program to illustrate this is the class parameter demo shown in the class materials. Some similarities to other languages. Many programming languages have a parameter passing mechanism known as call by reference. If you're familiar with the call by reference parameters, we should note that Java parameter passing mechanism is similar to, but is not exactly the same as call by reference. A quick pitfall to note, use of equals and equals equals with variables of a class type. You've already seen that the assignment operator used with the variables of a class type produces two variables that name the same object, which is very different from how assignment behaves with variables of primitive type. This for equality using equals equals with variables of a class type also behaves in what may seem like a particular way. The operator equals equals does not check that the objects have the same values for their instance variables. It merely checks for equality of the memory addresses. So two objects in two different locations of memory would test as being not equal when compared using equals equals, even if the instance variables contain the same value. And that's why, and we'll see here in a second, that we always use dot equals. Consider the following code. Toy class 2 variable 1 equals new toy class 2. And you can see it's a big long thing. We get Jana 3, variable 2, new toy class 2, Jana 3. If variable 1 equals variable 2, system.println equals, I think I forgot to put some breaks in here, else system.println not equal using equals equals. All right, a little bit of a convoluted piece, but you can see in here we are using to test things using equals equals. And this is what you really want to look at here. All right, this code was going to produce the output equal, not equal using equals equals. Even though if you look, they have the same value. Jana 3, Jana 3. Now, even though these two variables name objects are intuitive to be equal, they are stored in different locations in the computer's memory. Because remember, if we looked at how we talk about references, variable 1 is taking up so much space, variable 2 is taking up a different space. And this is the reason why we use an equals method when we compare objects of a class type. That's why, like strings, we don't say, a string equals another string, because instead we have to do the dot equals. Because when we have a class, we have to compare not the memory value, but we have to compare the actual value, and that's why we have to use the dot equals method. So the variables variable 1 and variable 2 would be considered equal if compared using the equals method as defined for the class toy class 2. So real quickly, I just want to pop over to Eclipse and just kind of show those. I'll open these two back up real quick here for you. So right here is our toy class, and you can see in here it's just a really basic, simple program. All right, in here we just have a parameter changer, and this right here will work those references that we've dealt with. And right here, you can see we have some other methods we're familiar with: sets, toStrings, equals. But this is the big one right here that is really going to deal with the references. And what this does is this changer method is a mutator method, and like I said, it's going to change the name to hotshot number to 42. All right, here's the demo that we might have seen before. And we look at toy class 2. You can see there's some similar stuff in here from what we had before, but we've added a couple more things to it. So, for example, we have a make equal method now. Right? And what make equal does is it takes toy class 2's object and makes it equal to the first object. So it's literally something to force one object to be equal to another object. Try to make equal will attempt to make the values equal. So here, try to make a number equals this a number. So it tries to make it equal to a value. All right. Here's our equals method again. And then, of course, we have some carryover pieces here. Here's our constructors. And then, of course, here is a changer piece. All right. If we look at our parameters demo, we can see in here that we have toy class 2 creates an object, and toy class, or creates two objects rather. We have a new toy class 2 and a new class 2. Object 1 is get to Scorpius 1, object 2 sent to John Critton 2. Print line value object 2 before call method, and then it prints it out. Then it says to make object 1 equal to object 2. Then the value object 2 after the call to method, print back out object 2. Right. Then int value is 42, so now print line value of a number for call, a number, try to make equal, a number, print it out. So if we run this code real quick here, all right, you can see that before we do the call, it starts off with the John Critton value, and then afterwards it changes to Scorpio 1. So this is just like what we saw with the variables. So it changes that value over. So this is how memory addressing kind of really gets in effect here. Right. Now, here's our int one here. So we have a number is set to 42. Right. And then when we try to make that equal, you can see that a number is still 42. Okay. But that's going to just kind of wrap things up for today, folks. Like I said, it's kind of like one of our last theoretical things, and we're going to, after this, start doing some applications of all this different pieces that we've been talking with references. So, until next time.